Here we have an example of a resistivity problem that could actually arise in real life. So this is a length of a wiring resistance problem. So for this one, we have a 12-volt car battery connected to a motor with a pair of 6-meter long AWG10 copper wires. What fraction of the power supplied by the battery is dissipated in the motor? And so we're just going to walk through a couple parts of this. The diagram on the side is going to be the one that we draw out. Hopefully you should be able to design this on your own. But the first part is the 12-volt battery put in the correct direction. Okay, we have a battery down. Then the next put is wire, 6 meters long. So we're not going to draw a 6-meter long wire, but we're going to draw two wires and say that those two are essentially 6 meters and they have this property. AWG10. So we might not have had this yet. AWG is a standard of wire thicknesses so that you can determine essentially how thick your wire is. And we have AWG 1, 2, 3, 10, all across the board. And each one of these is essentially changing the cross-sectional area of the wire and standardizing it constantly. And so we also have, what other important things do we have here? We have copper wires. So the wires are made out of copper, so we know the resistivity of copper. We can look that up too. And then we also have on the right-hand side the resistance of the motor as 2 ohms. So the motor's wires and all that internal wiring is going to be 2 ohms as well. So we're looking at what is the fraction of power supplied by the battery is dissipated in the motor. So essentially we're looking at an efficiency here. Are these 6-meter long wires really detracting from our efficiency? Is it going to be half of the power coming from the battery is just going to get sucked up into heat in these wires? Or is it going to be much less? Is it going to be 2%, 1%, 0.5% of the power, and the rest is going to go to the motor? So that's what we're going to solve here. I've written down below 3 individual equations that will be useful in solving this. You should already have these memorized, and the important part is knowing to associate these kind of questions with this kind of problem. So the first one is the resistance equation, which essentially this is a resistance problem. You're trying to look at how much resistance is in that wire. RC, if you look under the diagram, is the resistance of both wires. So that's 12 meters long of wires total. The rho there is going to be copper, essentially the resistivity of copper. L is the length, and then A is the cross-sectional area. So as I said, AWG is the essentially it comes down to the cross-sectional area of the wire, so we know we're going to get the A from that. The next part is Ohm's law, I equals V over R, and then the final part is the power, because it asks in the problem about the power supplied by the battery, what percentage is supplied goes to the motor, and power equation is IV. So now we're going to solve this one out.